So we have carbon with 4, nitrogen has a valence of 3, oxygen has a valence of 2, hydrogen very. Actually, hydrogen is the most common of all of the elements that we find in biological molecules, simply because it basically fills in the valences of all of these other elements. Because carbon has is tetravalent, it can form a huge variety of carbon skeletons. They can vary in length. They can also branch. They can form double bonds. And they can also form ring structures. And so variations of rings, numbers of double bonds, amounts of branching, variations in length, all of these contribute to variation in biological molecule structure and function. An example of a long carbon chain is what you find with fat. Fat molecules have a central group. We'll talk about this in our next lecture, but there's a central group on which you have attached 3 what we call hydrocarbons. Hydrocarbons because it's carbon covalently bound to hydrogen. So this is the normal, this is a structure filling diagram of a fat molecule. And what you're looking at here is a fat or adipose cell that we find. So whenever anybody goes on a strict diet, do you lose fat cells? No, absolutely not. What happens with fat cells when you lose weight, when you burn the fat that you have, is simply the fat molecules that are held in these little fat droplets in your adipose cells. The fat molecules will diminish so that the fat droplets go from nice big round size to little teeny tiny things. But when you go off your diet and start going back for those wonderful lunches where you have a plate of fries for the table and everybody gets 2 pieces of pizza, these things will round right back up again. So that's really the basis. This is the basis for why it's so hard for people to help to maintain a perfect weight, is because the fat tissue that you have developed when you were very, very young, less than a year old. Less than a year old, you develop all of the adipose tissue that you're going to have. And so from that point on, after you finish growing lengthwise and building muscle, then from that point on, all of that wonderful fat tissue that you had developed back when you were either breastfeeding or if you were taking a bottle of formula, that fat tissue is waiting. It's just waiting to expand or to shrink depending on what you had coming in. Okay? Does anybody have a question?
About a few slides ago, it was the balance. One more, yeah. So, is it that so the balance isn't the same as balance of electrons in the shell, right? It's how much it needs to complete the test.
Yes.
Okay.
So, and you're looking at the number of valence electrons in the shell. Okay.
So
So
6, right? 6 valence electrons, but 2 valence.
it has a valence of 2. The question is, what is meant by valence here? And that is valence 1, valence 2, valence 3, valence 4. That would be the number of electrons available to form an electron pair with another element. So, for example, carbon can actually form a covalent bond with 2 oxygens to form CO2. And it binds to oxygen here and here. All right. Okay, we'll go on. So let's talk a little bit now about isomers and how the tetravalence of carbon allows it to form these elaborate biological molecules. So an example of a structural isomer is shown here, where we have the exact same number. We have the exact same number of carbons, the exact same number of hydrogens, but they're just arranged differently. That's called a structural isomer. A geometric isomer involves the placement of a double bond. A geometric isomer involves the placement of a double bond and also the arrangement of functional groups around the double bond. Have you had this in organic chemistry yet? Yeah. So you understand the concept of the cis placement versus the trans placement. That has a huge effect on biological structure and function. Then we have enantiomers. Enantiomers involve what is called an asymmetric carbon. And around that carbon, you're going to have the same chemical groups, but they're going to be arranged slightly differently so that they're mirror images of each other. Okay, you've had this in organic already as well? Okay, good. All right. This is an interesting situation. What you're looking at here is the molecule thalidomide. Thalidomide was manufactured in Germany back in the 1950s, and it was given to pregnant women to ease the symptoms of pregnancy-related nausea. It's called morning sickness, but I can tell you it's 24/7. Makes life awfully miserable for about 3 to 4 months. And so a German company developed thalidomide as a means to ease